This is a video for the second chapter of zyBooks. So we're starting with variables and assignments, and we've already gotten an allusion to it. The first little task is a participation activity. You're just going to go through and check, and if you miss one, just hit check again and it'll reset it for you. So the first thing we're looking at is that a variable in a program is a named item such as X or number of people used to hold a value. So we want to look at this in more depth. So the assignment statement is X is equal to 5, Y is equal to X, Z is equal to. So you always say what the variable is on the left equals to what you're putting into the variable. So you can think of this left as like little boxes that are being held. And they're showing you here how that is. There's a participation assignment here also that you should do. Trace the variable value is one more starting through and checking to see that you understand where things are being put. The next one is just to enter the output of the variable assignments. I believe you're going to have more information in between here. I'm in presentation mode, so you should read through any of the information you have in between. But you're just getting an idea of what you're going to be putting in here. Note if it says print XY and it's asking you to type the program's output, that means that you put 8 and 5 and enter. Don't forget to put the enter. The next little section is on incrementing. And you can increment as in adding 1. Or you can add 5, but you're basically changing the value incrementally. So this is a little activity to help you to understand that better. The next little activity is a challenge one, and you're just supposed to put a line of code in here. So it says that you want the total points to be equal to the nickel count plus the dime count. So the sum of the nickels here and dimes. This output, sample output of 100 and 200, it does not need to be put into an input box here. And some of these have an input box, and there is no input that you need to do. You're just going to run this. Challenge activity 2.1.3 is just one line of code that you need to put right in here to multiply cell count by 10. Cell count equals cell count times 10. So in the 2.2 lab, it says that you're going to need to put some input in. And you see that this lab activity does have an input block here, an input slot. So make sure that you do put your input in there before you run your program. You have a develop mode and a submit mode. Remember, you have to hit the submit mode in order to actually submit your answers. So here it's saying we want to write a program. We have usernum as one of the variables. We have X as a variable. Both of those are input. And output usernum divided by X 3 times. So that could be done in one line, or you could take 3 lines to do it. Usernum divided by X, usernum divided by X, usernum. Now it's assigning it to usernum each time. Now there's a little note down here that gives you a hint about using the double slash bars, which discards the decimal. And here we're using integers, so we want to maintain the integer capabilities here. So when you do this, you're going to have an integer left over. You'll need that double division. So note that you do have to put input, and they do give you a sample input that you can try here. And then you should get this output if you've done things correctly. So 2,000 divided by 2 is going to give you 1,000 divided by 2 will give you 500 divided by 2 will give you 250. And you should try this. Well, actually it does. It has some tests that it's going to try. So when you do this, there'll be some tests that it tries, and you can see that they've used it with other kinds of numbers. If you try this with maybe 2001 or even 11, you're going to see that your integer results are going to get rid of the fractional part. An identifier is also called a name, so it's like your variable name. This is giving you what you can use for those variable names. So it's a sequence of letters, either upper or lowercase, an underscore, and digits 0 through 9. It must start with a letter or an underscore. Name is defined exactly the same. I don't know why this is underscores defined this way. It looks a little weird. It may be different in the outside of the presentation view. Case sensitive means uppercase or lowercase. So if you have, it says here that Python is case sensitive. So if you type a capital C and the variable is actually a lowercase c, then it's going to give you an error. And it'll probably be a syntax error because it's not written correctly. We also have a group of reserved words. Every programming language does have reserved words, but notice that print is not on this list. Print with the parentheses around it is actually a method, and it's not a reserved word. You don't have to have these memorized, but we're basically going to see each of these as we go through the Python course. 2.3.2 is letting you try to find names that are going to be valid. So for instance, if I put in the word if here, I can see it's on my list of keywords. Try to validate, it's going to say it's a reserved word, so it's not going to let you do that. But if I put if else and validate, if else is a valid identifier. Both of those words are on my reserved words list, but if else itself as a word is not. Any item that is stored in a program, like here, x equals 7, means that we created a variable x and we put 7 into it. Now I'm going to be able to use x anywhere else. This is usually called an object in this time of object-oriented programming. So here we have one object being created. Everything else is just lines of code that will be executed. We only have one item stored in memory. Now, these objects are being created and stored in memory, but once you close your computer, you would like for those to go away, and it's a good thing that they do. That's called garbage collecting, and that happens pretty much automatic with any of the programs that you use, any software you use. Name binding is the process of associating names with interpreter objects. Here we set Bob's salary equal to Tom's salary, but Tom's salary was adjusted on the next line. It was incremented. If we put Bob's salary and Tom's salary together, you can see that it did not increment Bob's salary even though it was equal to Tom's salary. So this third statement here only assigns Tom's salary at that statement. It doesn't keep reassigning when Tom's salary is changed. That's a different process. You could have that happen in programming, but if you're just assigning statements like this, assigning variables, then you're not going to have that happen. You can have values either stored in variables or just being printed as a value itself. Like down here, print 5. 5 is a value and it's being printed. This print 5 here is a value that is printing the actual string 5, like the string 20 here, because there is no variable that's being attached to this. This implies that it's integer notation, so that means that x is actually an integer here. There are no quotes here, so x is actually going to be 2 plus 2. So this turns x into an integer automatically. I didn't have to say it was an integer. The type function actually prints the type of an object, so when you get an opportunity, you might use this type function and see what it actually does. It's important to understand what things in your program are mutable or immutable. Mutability means that you can change the value all over the place. Immutable means that you can't change those values, and if you modify a value with something that's been assigned somewhere, then it actually creates another object. Now, either the original object was left stranded, or, as they say, orphaned, or it's taken care of in garbage collecting, and usually it's taken care of in garbage collecting. There are some programming languages that are a little bit clunky, and you have to make sure that you get rid of objects. Python is not that kind of programming language. It's pretty good about garbage collecting. The ID function provides you with the value of an object's identity. We'll play with this a little bit, but unless you're actually trying to compare objects, you don't really need to know a whole lot about the object's identity. This is used an awful lot when you're comparing objects and perhaps software that you built and you have identities of people that are being stored, profiles. 2.4.1 does allow you to run a program so that you can see what these different things, the type, the ID, and the string would do for different kinds of objects that have been created. These are objects. The birthday year here, 1986, should actually be a number, and you can see how these are being stored and how that would be represented for each of the value, the type, and the ID. So floating point 2.5 introduces the float type, the data type. We've been working with the int type an awful lot, but we're going to now look at things that perhaps have decimals. Just because you have a floating number does not mean that you have to actually show the decimals. You could have the number 1.0000 and you want to actually present it as an integer, have it show as just an integer. So floating point literal is written with the fractional part even if that fraction is 0, like I was just saying, 1.0. So that's what I was talking about. 2.5.1 shows you a few lines of code for the float types. So miles is a float type, and I'm dividing by float type. You could play with this a little bit, not in this window, but you could play with this a little bit and see what happens if you don't put float in here. Miles comes in as an integer. You can also use scientific notation for a floating point literal. You can't, well, there is a way to write it like this so that you could actually have it stored this way. But here I can write 6.02 times 10 to the 23rd with a little e in between. And you'll see down here, that's what we would do. So this is making this variable, joules per TNT ton, into a floating type that's actually in scientific notation. So our print statements here are going to have the number of AA batteries in here. And notice that it's got some pretty large decimal places, a large number of decimal places because of some of these float values here. So pay attention to what the decimals will look like if you don't actually format them. We'll talk about formatting later in the chapter and in the book. Some of your calculations may result in an overflow error. And here they show you what that traceback is going to look like. And they're basically a traceback is telling you where you might be able to find your error. So here it says that any number from 1.8 times 10 to the 308 and then 2.3 times 10 to the negative 308. So you get a positive or negative value, doesn't matter, but any number within this range from 2.3 times 10 to the negative 308, which means a whole lot of floating points, that's virtually zero, but you could use scientific notation for this kind of number. Anything else is going to give you an overflow. This next section, manipulating floating point output, shows you the format that you would have to put in order to get some float notation out. So what you're going to do is have a regular print statement, and this part here is a placeholder for the variable that's in the dot format statement. So if you have more than one, you'd be dot format and you put each one of the ones you have separated by commas so that you can put several different ones in. So there's a little participation activity that you can play with. But note the flotation, the format for the floating point numbers is how many decimal places you want. There's a colon, how many decimal places you want, 0.2, and then F for float. So you have to have the brace, this whole thing. So this is the time where you want to write this down and make sure you're memorizing exactly what the flow of this particular line of code is. So this is formatting a print statement. Here, remember that if you had default output pi and then comma, I'm actually putting this in. This is going to put a space after the colon. There's no space in here, but it does automatically, just a reminder. The end equals, with the quotes in between, is going to put a space. If there was no space there, it wouldn't put a space. But with the quotes in between, allows you to go to the next line and format it. This entire little section here could have been formatted just by using these placeholders with format like this. In the 2.6 lab, you can see we want to do a lot of entering of variables and printing out some lines after those variables formatted. So I want to this new character function, which will convert anything to its character, equivalent character representation. So they've given us the first user input line, and you're going to want to put more of those user input lines in. Notice the /n, the \n. You could have put an end in here with the quotes in it, but they want the thing to print out exactly the way that it was in the previous example. So going back up here, we should have an integer. This should print on the screen, and then it should be on the next line that someone enters something, and then the inner float will be the next thing that you're asking for. So that's a prompt that you're putting inside a print statement and collecting a float instead of an integer. And then you're going to enter a character. And then a string. Then I want you to print something out. So you could copy these lines exactly how they are and just put them in your print statements. But you're just going to follow the directions pretty easily. So in here, the fix me 1 is this first part up here, and then fix me 2, and then fix me 3. So you want to put the lines of code where they belong in this lab. Reminder that you can come see me at my office hours or ask for separate office hours so that we can go over any of these if you need to. In the 2.7 lab, I thought this was a little strange because they're asking you to enter the amount of lemon water and agave nectar to make however many servings you think that's going to make. So basically you can enter nonsense here and you'll end up with the kinds of things that they have here. Notice this is formatted to 2 characters, and they've given you the hint here that this is how you're going to do your format statement. You might consider trying to put all of your things printed out in one format statement when you print it like this, but you can do one line after the other and it goes to the next line. This program does require some input, so a reminder that you do have to put your input one line at a time here for the 3 things. I think it's 3 things you're being asked for. No, it's 4. 4 things that you're being asked for. I recommend you put their suggestions in so that you can compare it to their results. In 2.8, we define some more terms, in this case, arithmetic expressions. Anybody that's taken mathematics has talked about expressions in mathematics, but you probably don't remember that very well because we don't usually keep reminding you of it. We just say, calculate this or simplify that, and they don't actually say expression. Sometimes they do. So this is an expression. I can use the expression in a statement. This is an assignment statement, y equals. So if it has a y equals, that's an assignment statement that you're looking at. An expression is just something like this. Even the number 2 is an expression. A literal is a specific value in code like 2, but I'd call it an expression if I was a mathematician. And an operator is any of the symbols that you can do to perform calculations. So they're showing you the list of operators here in table 2.8.1. In the participation activity, I'll give you a little hint that if you're going to do multiplication in any programming language, 2x sounds like multiplication anywhere you see it in math, but we're programming, so you'd have to put things like 2 times x. 2.8.2 just has a few more activities in pretty much the same line as trying to understand exactly what you should be typing to get the result that you're wanting. Evaluation of expressions actually follows the order of operations from mathematics, which says that we're going to do parentheses, exponents, and we're not talking about exponents yet, so it's not here. Multiplication and division in the order they appear, and in Python, the negatives actually are attached to the number first. So that's negative times a number, so it's actually multiplication doing there, but here it's trying to emphasize that that negative is going to be attached to whatever variable that it's in. The multiplication and division and percent in the order that they occur. They have equal level of precedence, so you'll have to be very careful when you're coding that you get the calculations the way you actually want them to happen. And then of course multiplication, division, addition, and subtraction in the order they occur, again with equal precedence. And then if more than one operator is of equal precedence, left, right, just like we said, in the order they appear is what this is saying. So in the 2.8.4, evaluating expressions, this is really just seeing that you understand the order of precedence. So work through these very carefully. Just below this activity, the last activity, using parentheses in the correct order, they're basically showing you that the good practice is to put in parentheses where you think it should be, so that you make sure that it actually is being computed the way that you would like for it to be. So they give you an example down here of the calorie expenditure problems, and there are all kinds of parentheses put in here in brackets. So take a good look through these and see that you really understand the notation. The 2.9 lab is practicing formatting. So this format statement I'm going to need, so I'm going to copy and paste this down here into the lab. So at some point I'm going to need this. I'll put a few lines down because I'm not sure where it's going to need to be. Now you can make your variables your value 1, your value 2, your value 3. So I'm just going to copy this and make my variables that. Or you could name them something else and replace those with your variables. So here they're asking for some input. So you'll have to put some input in here for sure. But let's go back and see what that input needs to be. So it's cars, miles per gallon, and gas dollars per gallon is what we're wanting to put in. So I'm going to need some print statements that actually ask for those. So I want to enter your cars, miles per gallon, and far as gas per gallon. Notice this is black and blue here, so there's definitely an escape character that I need with this. And I don't actually want this printed. I want this put as an input. And I want it to be actually put in my miles per gallon. So I'm going to put MPG as my variable. You can put whatever variable you want, equals. I want it to be float. And I want it to be an input of this. So I guess I'm going to need parentheses here. Input in your car's miles per gallon. And I'm also going to want to do the same kind of thing with gas dollars per gallon here. Note that there's an escape character that I need here. You'll have to have an equals for these. Read back through the instructions as to what you should have here. You may need to declare floats there depending upon how you are going to type up your answers. These are placeholders for the corresponding variables that are in your list of formatted items. So you just have a little bit of work to do here. You might copy these and paste them down into your input so that you can check your code. The 210 lab is more practice in working with formulas and working with formatting. Note that the formula is already given to you here if you keep the same variables that they have. In fact, they put a comment statement in. Now, comments can be done with hashtags, or they can be done with these 3 quotes like this. So if you put in 3 quotes, you can put in comments. But hashtag is how we'll generally do it. This is acceptable. But they already do have these in here. You could get rid of, well, probably you want to leave it, but you could copy these lines and get rid of the parts that are commented, and it'll work just fine. Note that you do need input here. 2.11 is on Python expressions. So there's a little bit of code there and some questions concerning that code. Though it's not required, the style that we put these in is actually to put some spaces in. So if we have something that looks like this with spaces around the times, it's a little easier to see, and spaces around the equals. So I'm going to be looking for that, and I'll dock you points if you aren't willing to adhere to that format. It is a suggested format. It's what everybody uses in the industry. So it's not required with Python, but I am going to require it for this course. The compound operators are shortcuts for doing things like adding, subtracting, multiplying, dividing, or the percent here. We haven't worked with that yet, and we will. The percent is actually having a remainder, which is modulo, and actually might have worked with percent in the first chapter, briefly. But we will be working with that a little bit more. It's very popular with programmers, finding the remainders. So the number of atoms is initially 7. What is num atoms after num atoms plus equals 5? So this is the same as num atoms equals num atoms plus 5. That's what that's the same of. It's exactly the same thing. So up here, age plus equals 1 is the same as writing age equals age plus 1. Num atoms times equals 2 is the same as writing num atoms equals num atoms times 2. It's just short notation. And here they're asking you to rewrite this with compound notation. So this is really easy. I will test you on this. You will need to be able to use the compound notation. Commas are not allowed in assigning an integer literal. So you can't put commas into your numbers here. If you put a decimal, if you're European and decimals are where we're putting, in America, we put commas, you can't put decimals except for where decimals are. That 1 decimal place, right after the ones place, and before the tenths place. Note that 2.11.1 actually has just a run statement. You don't have to put any input in. It will be running tests. You can see the tests are being run over here. All you need is 1 line of code here to compute your average. In order to get it to look like a float, you're either going to have to cast it, like putting the float in front of it, or you're going to have to do divided by, in this case, 3 cells, divided by 3.0, which would be dividing by a float. Either way will get you a float result, and you can try that running the program here. 2.11.2 is about programming the volume of a sphere, and they give you the formula. It's not in Python notation, it's in math notation, so you're going to have to think about what this is going to be. In order to get a cube, you could do r times r times r, whatever you're going to show. And here it's a sphere radius, so it would be sphere radius times sphere radius times sphere radius. Or you can do the power thing with the math. I recommend you do whatever simplest for you here. Note that pi is already given to you, so you're not having to think about where you're going to get pi from. In 2.11.3, there's a formula given to you for the acceleration due to gravity, and that's what this is really about, acceleration due to gravity. And we're formatting it. It's telling us that we're formatting it to do decimal places. There's no input needed here. It's being able to pass tests, putting in different kinds of notation. So really you just want one equation here that is going to give you the acceleration due to gravity. 2.12 is about division and modulo. Division we pretty much understand. We're just dividing it out. 20 divided by 10 is 2, 50 divided by 50 is 1, and this would be floating. 5 divided by 10 is 0.5. If you use a double division, now if you're assigning this to something that's already integer, sometimes you want to be a little bit careful. So it depends upon what you started with, whether or not this is going to work the way you want to. So make sure you're checking your programs in case this actually ends up doing 5 divided by 10 is 0, because it's not allowing, this is integer division. So make sure you're very careful about how you're doing that. Python works a little differently than other programming languages like Java. So you just want to play with it long enough so that you understand what your results will be. So here they're talking about division and floor division. Floor division means you're just truncating. You're getting rid of the stuff after the decimal. Floor division. Ceiling division would be rounding up. And we aren't really going to talk about that here other than the 2 seconds that I spent on it. If you really can't do the division that's described in this exercise, make sure you're putting in error. So as you're going through the Zybook, you want to make sure that you're actually following instructions pretty carefully. Modulo operator, which is the percent that's above the 5 on my keyboard, it gives me the remainder. If I did 24 divided by 10 in float, that would be 2.4. 24 divided by 10 when I do // the double slashes, would just give me 2 because it would get rid of any of the decimals. But 24% 10 is going to give me the remainder if I divide. So 24 divided by 10 would be 2 with 4 left over. So the remainder is 4. The modulo is the remainder. Make sure you play with this a little bit because it's real easy to get this confused. The typical thing that happens is people are playing with how many minutes and figuring out exactly how many minutes, seconds, and hours for some particular kind of time. 2.12.2 is just checking your understanding of what this modulo actually does. 2.12.1, you're going to have to enter the answer as what it's going to print for y here. So 9.5 would be the input maybe. Or if you thought 19 divided by 2 was supposed to be 9, then you'd put 9. So if you check this, and I'm going to check it to see what it looks like. Oh, I need to start it first. 6 divided by 5 would give me 1.2, right? I'm going to check this. Now, if this is both of these are integers, so if I do 1.2 and do the division, I could end up with 1, or I could end up with 1.2. So let's see if this is right. Your output is nearly correct. So you can see in Python, I have to check it again. No, I have to do next. Next will put me back at it. And then if I hit enter, I have to check. Because this actually takes to the next line, and part of your answer is to take to the next line. So if I do next, it's going to give me another one, and this was the double. So this is where we're going to get an integer. Now, the reason that I keep alerting you to the fact that we have integer division is that in Java, it's heavily typed, and if you had done 17 divided by 3 in Java, you would have gotten this result. Anyway, this would have given you the floor division. So if you come from another language that's heavily typed, Python is a little easier to work with. So in the modulo examples here, they're going to show you how to get some digits out of this. So these examples are very helpful when you're trying to get any kind of digit out of a particular one. This is a typical thing that's done in programming if people are looking through people's profiles and trying to find particular items about them. 2.12.3, you just have more modulo examples. So if you can get these right the first time if you're really paying attention and you study the modulo enough that you understand it. 2.12.2 is going to have an input, and the sample input they're saying here is 19. And it's just going to convert it to how many $5 and $1 bills that would be, with $5 bills being taken out first. So for instance, if I had $40, that would be 8 $5 bills. If I had $3, that would just be 3 $1 bills. So that's what we should be seeing here. 2.13 begins the module basics, and that's a little more than what I'd like to carry out in this video. So look forward to a second video for chapter 2.